Good morning, everyone. I'm Himali Tandon. Today, we have the distinct pleasure of hosting Mr. Suryansh Rana, co founder and CEO of Ithara AI, for an insightful session on fine tuning large language models with a focus on post training technologies. Mr. Rana is the co founder and CEO of Ithara AI, one of the few Indian organizations partnering directly with global frontier labs on the next generation of large language models. Under his leadership, Ithara AI has grown into a 3,000 plus person team working on reinforcement learning environments, feedback systems, and evaluation pipelines aimed at bridging the gap to AGI, artificial general intelligence. The company currently processes over 50 billion tokens every month and delivers more than 6 million hours of training data to teams working at the forefront of AI development. Mr. Rana's journey into AI began in the United States, where he studied electrical and computer engineering at the UCLA. He later gained experience in California's electric vehicle and clean energy sector before returning to India in 2023 to co found Ithara AI. With expertise spanning reinforcement learning, agentic AI, and frontier AI systems, Mr. Rana brings a unique perspective of how models can be trained to reason, adapt, and operate intelligently in real world environments. Please join me in giving a very warm welcome to Mr. Suryansh Rana.
Hello. Hello, everyone. Hello, everybody. It's almost 12 p.m. I think we can gather some more energy, right? Good afternoon. Okay, slightly better. So, my name is Suryansh. I'm the co founder and CEO of Ithara AI. Ithara is a deep tech AI research lab. And at Ithara, we do one thing: reinforcement learning to fine tune large language models. What that basically means is that we build the data pipelines that fuel the frontier models that we use today. Now, this is not going to be more of like a speech. This is going to be a bit of a conversation. So I want everybody to participate here, right? What are frontier models? Can someone name a frontier model? I'm sure you all use it. Yeah. Can you say it louder? Chat GPT. Okay, that's a frontier model. Gemini, that's another one. Claude, I was waiting for that, right? That's probably the most popular today. I think ChatGPT and Claude sort of take the cake, right? So we're building for these frontier models. So these are the kind of AI models that we train, right? And as the kind lady mentioned, we are one of the very few companies in the world that actually do this, right? And building this level of expertise takes a lot of courage and also a lot of research, which is essentially what we do at Ithara. So to reiterate, we are a deep tech AI research lab that provides reinforcement learning to fine-tune large language models. Now, I know that's a lot of words and that's a handful, but it is super important to understand the meaning of each if you are trying to work at the frontier of AI model training. Now, I was just recently told that this audience is a mix of some MBAs and BBAs and BTech students. But let me make something very clear. To work in at the frontier, right? It does not matter what your background is. Okay, whether you come from a humanities background or a technology background, right? I have seen pioneers and leaders of the world who have majored in philosophy and are running companies like Palantir. Okay? So please don't think that just because you have a specific background, you don't fit in a technological space. I think that's the biggest misconception. And today we'll try and clarify and debunk that myth. Okay, are you guys with me? Yeah, sounds good. Awesome. So, just to give you guys a couple of company highlights, we are a team of over 3,000 post training experts. This ranges across various departments such as research, engineering, and data operations. Every single month, we process nearly 50 billion tokens, right? Just for clarity, the models that you use today are roughly somewhere around 1 million to 5 million tokens is the consumption on average. We process over 50 billion tokens a month. Over the last 3 years, so the company is approximately 3 years old. Over the last 3 years, we have already contributed more than 6 million hours of human curated data to train the frontier models that we are all using today. I think that deserves a round of applause, right? So, what's next, right? We already have models like ChatGPT, Gemini, Claude. Now we have open source models, DeepSeek, Quen. So all of these are coming up. GLM 5.2, really breaking the benchmarks these days, right? So what's next, right? We've already we are sort of hitting like the pinnacle of AI today. But the question is, are we really, right? And that's what we're going to explore in today's conversation. So today's topic, from text emitters to thinking machines, we are going to cover the evolution of artificial intelligence, right? From being these glorified chatbots or fancy autocompletes to something that can actually think, plan, act, and learn. But before we proceed further, let me ask a seemingly simple question, right? Are the SOTA models, or state of the art models, that we use today truly intelligent? To answer that question, we'll have to borrow a framework from psychology: crystallized versus fluid intelligence. Now, this is not something that we came up with, it comes from the cattle horn Carroll theory of human cognition. And it applies surprisingly well to what we have built in AI today. So let's take an example of crystallized intelligence, right? What does crystallized intelligence mean? Think of, how you study for exams, right? You read a textbook, you learn a couple of formulas, and then you go and apply it to a problem in your exam, right? So what is that? That there are two key things that are at play here, right? What do you think that is? What is the first thing? When you're reading a textbook, when you are reading your class notes, when you're reading a presentation, what are you trying to do? Learn, yes, but what else? Memorize. Memorize, right? So the first thing at play here is memory. You're trying to memorize the content that you are learning, correct? What's the second thing? When you're actually giving that assessment, when you're taking the test, what are you doing? You're trying to recall. Who said recall? Nice. You're trying to recall from memory, right? So there are two key things. You're trying to memorize and you're trying to recall from memory. And you're trying to apply that with extreme precision, right, to get to the answer, right? That is the definition of crystallized intelligence. This is a simple example, right? So this is a calculus equation. How many of you can solve this? Can I get a show of hands? Okay, not many of you, which is surprising. This is, yeah, right? Like, it seems daunting, right? But when you slowly try to recall from your memory, you must have done this in the past 100%, right? At some point. Now you're trying to recall from your memory, okay, how do I apply the chain rule? Do I apply the product rule? What do I do? Right? So let me tell you that the purpose of showing you this example is that an AI can not only recall but also apply with extreme precision the chain rule which is required to solve this equation in under 3 seconds. Now, how many of you can solve this in under 3 seconds? Right? That's a rhetorical question. No one. But that's actually the power of AI today, right? And that's how good AI has gotten at crystallized intelligence. That's how well it has amassed the knowledge that exists today in the world, or memorized the knowledge that exists in the world, right? That it's able to recall from its memory and give you an answer in less than 3 seconds. And this is just one example, right? You can see this in the homework assignments you're probably giving today to ChatGPT, right? You can probably do it, what, in under a minute, right? Yes or no? Yeah, okay. So I've been a college student as well not too long ago, right? So I can totally relate with where you guys are coming from. And I didn't have AI in my college life, but I know what I would have done with it, right? And I'm sure you guys are leveraging it as much as you can. But also make sure that you are using it to learn, right? And not just get the answers. Okay, so let's understand how good AI models today have gotten at crystallized intelligence. Okay, so there is a very popular, technique, or rather we can say concept, right, of benchmarking. Okay, how many of you know what a benchmark is? Okay, what do you think a benchmark is? It's in the name. Anyone? Sorry. Uh, in the what? Thank you.
I was telling that like benchmarking means that at that particular point of time, it is the best in its own categories, like
Okay.
that.
Okay. Interesting. Best in its own category. All right. Anybody else? What is a benchmark? When I'm benchmarking three AI models, what am I doing? Comparing, right? Comparison. I'm comparing different AI models on a benchmark, right? To see which is performing better. How do I create a benchmark? Now, this is super important to understand because benchmarking is one of the key techniques used today to evaluate how far AI has come, right? So, benchmarking is something very simple, actually. It's basically a set of tasks. Okay, what is a task? A task is just anything you give an AI to solve, right? It could be a homework assignment, or it could be, a calculus problem. It could be anything. Anything that you give an AI model to do is a task for the AI model. Okay, are you guys with me? So what you see behind me over here is something what is known as humanity's last exam. Okay, this is a benchmark that was created by a group of PhDs and domain experts from around the world to create one of the hardest examination style benchmarks or tasks for AI models to solve. Now, it was released in late 2024, and when it was released, some of the best models like ChatGPT, Gemini, Claude scored approximately 3% on this benchmark. That means they only had a success rate of 3% in late 2024. But today, those same models have climbed up to nearly 50%. Now, that is a staggering rate of improvement on something that we literally call humanity's last exam, right? So, this goes to prove that models have kicked our human butts when it comes to crystallized intelligence, right? They're able to recall very efficiently from memory and apply with extreme accuracy the knowledge that humanity has learned over many lifetimes. So let me ask the initial question again, right? Are the models today truly intelligent? How many of you think yes? Can I get a show of hands? Okay, you don't think they're truly intelligent. Can anyone tell me why don't think that they are truly intelligent? Anybody? You didn't raise your hand, so I'm assuming that you feel like they are not intelligent, or you say think that they are intelligent, but you're too scared to raise your hand. It's either one of the two, right? Guys, come on, I need some more participation here. Participation is a good thing. Thank you.
They are not truly intelligent because they can't do anything without giving them the source material beforehand.
Very nice. What's your name?
Nikunj.
Nikunj. As Nikunj said, that they can't do anything without prior source material, right? That is a super interesting point that he makes. And the reason being that, yes, they have become very good at crystallized intelligence, but have they truly mastered fluid intelligence, right? So let's understand what fluid intelligence means, okay? Fluid intelligence is the ability to solve novel problems without any prior domain knowledge or experience, or in the words of Nikunj, any prior source material, right? Let's find out. So at Ithara, we ran a very simple experiment, okay? We built a 2D puzzle, very simple 2D puzzle, and we gave the model and the human side by side. We put them side by side, and we gave them both four controls: up, down, left, and right. And we basically said, figure it out. Here's a puzzle, here are your controls. Now you have to understand the puzzle through trial and error and figure out how to solve the puzzle. This is supposed to be a video. Okay. I think the video is not playing. Can someone help? The point here is that the LLMs or the models were not able to solve the puzzle at all. They kept going into a loop of trial and error, but they could not understand what it was that they were trying to achieve. Now, to solve a puzzle like this, do you need any prior domain knowledge? Yes or no? No, right? It's very simple, it's intuitive, it's instinctual, and it's something that you have experienced over a lifetime. Thank you. Okay, on the left hand side, you can see, thank you so much. On the left hand side, you can see the human. You can see the pace at which the human is trying to solve the puzzle, right? You can see how quickly a human is able to learn from their mistakes and iterate to achieve the goal. Whereas a model on the right hand side is barely even able to understand what it is looking at. I think this goes to prove my point, right? That AI today has, although has mastered crystallized intelligence, it still has a long way to go to master fluid intelligence. Now, this is a benchmark, again, released by the ARC Foundation that basically shows the number of steps a human takes to solve these puzzles versus how many steps an AI takes without even solving a single puzzle. You see the gap, right? You guys see it or not? In humanities' last exam, models were able to solve PhD level questions, right? But when given a simple 2D puzzle, they score a flat 0. And that is the gap to AGI. Who all are familiar with what artificial general intelligence means? I see one hand. Okay, these are concepts that you should definitely be keen on understanding. How many of you are interested in AI? Can I get a show of hands? Okay, majority of you. So, if you are interested in AI, I highly recommend that you start reading up about what is happening in the world today. Okay? This is very critical because the space itself is very new. Okay? So there is not a lot of standards that have been set. Like, it's not published in your textbook today, right? If you open your school textbook, do you find a chapter on, maybe, yeah, because now you've released AI courses, right? But let's pick up a textbook from 5 years, 10 years ago, right? Is there even a mention of artificial intelligence? The words AI, do they even come together? No, right? So how do you keep up with this fast-paced industry, which is literally changing every 2 weeks? How do you do it? You have to be self-motivated. You have to learn, self-learn, and you have to apply. And that's the key. Okay? So until and unless you are making that effort on your own to go out and read up about these latest technologies, what is happening around the world, you will not be able to keep up with the pace at which AI is developing today. So we've established that models are super good at crystallized intelligence, but are still struggling miserably at fluid intelligence today. At Ithara, this is the gap that we are bridging, the gap to AGI. So how do we do it? What is our process, right? Now, again, I want to reiterate that this has nothing to do with the major that you are taking up today in college. These are techniques that anyone can pick up on, and they are being applied across all domains, not some, but all domains. Because the necessity today is that AI must master all fronts, correct? Not just coding, not just math, but humanities, accounts, everything. Because there is a use case for AI in every single domain. But the question is that how do you train a model or fine tune a model in different domains? Well, the techniques are called supervised fine tuning or SFT, RLHF or reinforcement learning through human feedback, rubrics, and many more. So if you are interested in building a model or fine tuning a model for your domain or for any domain for that matter, you must start becoming familiar with what these techniques are. Because ultimately, it's the data set which allows you to train the model. Rest, everything has been pretty much standardized, but what is really lacking today is high quality data. So, although these techniques have been the traditional playbook, right, where the frontier labs today are relying on these techniques, the problem is that they have hit a wall, right, and that's the saturation that we were talking about earlier. Their models today have become exceptionally good at recalling from memory and even aligning with human preferences. But that does not mean that they are good at learning from their mistakes or adapting to new environments, which is what we saw in the ARC AGI graph. So, as I said, that the frontier of models are changing, so is the frontier of model training. Every few weeks, there are new techniques coming out on how to better train the models, right? So in the old world, the way we train models was that we simply put a text input, we let the model process that input, and then we evaluated the output, right? It was a very simple process where whatever input you gave, the model would produce two outputs. And as a human domain expert, someone would be sitting there and selecting which is a better output, A or B. All right? Simple, right? But this very quickly hit a wall. Models were not learning how to learn from their mistakes. They were giving very polished outputs, but they were not actually adaptive. So, in the new world, we have built a new framework where we are now teaching the models on how to observe, act on their observations, and then learn from their mistakes, making the models more adaptive, robust. And the key word here is agentic. Okay? How many of you know what AI agents are? Can I get a show of hands, please? AI agents. You must have heard of agents before, right? These are not the agents from the Matrix, or could be. But agents are, okay, guys, if you don't know agents, you are really falling behind in AI. Okay? Like, this is probably now the baseline of getting a job today in any sector. You have to learn how to build AI agents because you now need to start delegating the work to agents to make them do it faster and more accurately. Okay? So essentially, what we are doing at Ethara is we are giving the models the capabilities, the agentic capabilities, where the models can now observe, act, and learn. So there are 6 key things that make a model agentic. Okay? And these are the 6 pillars that we at Ithara rely on to improve our models. Planning, tool use, reasoning, memory, perception, and adaptability. Think of yourself, right? So think of you while you are doing a task, when you're solving a problem, anything for that matter, not just in academia, but anything even outside your school, right? Do you use all 6 of these pillars? Yes or no? You do, right? You have to. If you don't plan, it's not going to work because you won't know what to do, what actions to take, what steps to take. If you don't use tools, it's going to be highly inefficient, right? If you walk to college versus if you drive to college, there's a stark difference, right, in the time that you get there. So that's a tool for you. Reasoning. When you're driving to college, you try and dodge all the bikes and the autos and the buses, right? So you're reasoning on what is right, what is ethical, right? Memory. You need to remember where your college is to get there, right? Perception. You have to be able to see, speak, and hear, right? To make sure that you get there in one piece. And adaptability. Well, I think that's pretty much self-explanatory, right? In driving in India is the epitome of adapting. So we do that every day. All right. Our research. How many of you here are interested in research? Okay. So our research at Ithara focuses on something what we call long horizon tasks. I think we defined what a task is, right? It's any job you give to an AI model, right? Now, it could be as simple as giving the model 1+1, which I highly recommend not to do because it takes a lot of power to even compute that today, right? So if you're giving something a model like that, you're literally burning our environment or our world. So let's not do that. But let's think of more as a long horizon task, right? Let's define long horizon. It's something that would take an engineering team about 6 weeks to build out. Now, this could be a full-fledged functionality of an app. This could be refactoring a massive chunk of a code base. Or this could even be writing your thesis as a PhD with empirical evidence, setting up experimentation designs, running those, validating those, and then finally concluding on the entire thesis itself. This is what we call a long horizon task. Now, why is it important for us to build capabilities around long horizon tasks? Because models have become already pretty good at short horizon, right? You give it, and I'm coming back to your homework assignment because I think that's most relatable, but it's pretty good at that now, right? You don't need to keep prompting it and keep telling it that it's doing it wrong or right. It gets it, right? But when you talk about building or developing a new medicine in pharma, or when you talk about building a new battery technology, right? That is an open-ended problem statement that requires the agents or the AI model to run multiple rounds of iteration, learn from its mistakes made in the past, and improve the output at every iteration. That is the focus of Ithara on how to build AI capabilities to solve these long horizon tasks. Now, this is an example of long horizon tasks in software engineering specifically, where we're giving the model a massive code base and we're giving it a chain of pull requests, which basically means different, different tickets to solve for on a massive code base. Okay? And what we're finding out today is that models are not good at doing this. So models have not yet built the capability of achieving long horizon tasks. And this graph for us, so this is our own benchmark that we released. It's called the Milo bench. And the Milo bench proves that anything above 81 to 100 pull requests, the model performance essentially collapses to a zero. And this is a very important graph for us, right? Can someone tell me why? As a company that does reinforcement learning or that does model training, why is this graph important for us? Come on, guys. I know someone has the answer here. Okay. What is the objective, right, of training models? It's to it's to achieve 100% accuracy across any task, right? Where if you're building a model, would you not want to build the best of the best models? You would, right? So when you're doing that, and when you find out that, oh, your model is actually failing after just 81 pull requests, what does that mean? It means that you have a ton of headroom, right? So anything between 0 to 100, which the model is not able to achieve, is opportunity for us as a model training company to build out data sets to fine tune these models. And this is valid. I mean, you can build a benchmark at home very easily, actually, right? In your domain. All you have to do is build out tasks which are super difficult for the model to solve. If the model stumps or if the model fails, you know that the model lacks the capability to solve those type of problems. And that builds room for opportunity for a data services company like ours. And you can build one too, right? And this is the opportunity that we look for in all different kinds of domains. So this is a very simple and straightforward flywheel that shows our process end to end. It starts with a benchmark data set, right, or a set of very hard tasks on which we evaluate the model and find out the headroom that is available for the model to train and learn. The second step is to build a custom harness, which basically mimics the environment in which the model is supposed to operate. We then perform inferencing, which basically means that we are running the model on these tasks using that harness, and the output of the model is what is evaluated. So the output of the model is not just a single number or a single sentence. In this case, it's the entire model trajectory or the trace. What that means, literally from step 1 to step 200, whatever the steps the model took, that is what we call the model's trajectory or trace. And we evaluate that model trace using a set of system evaluations or rubrics. So these are basically rules that we set out for the model before the model executes the task to check whether the model adhered to those rules or not. Are you guys following? For example, let's take an example, right? I tell the model, solve that calculus problem that you saw earlier. But I also give the model a simple instruction not to use the chain rule, but to derive it and then use it. Right? That's a rule that I'm setting in my input. And then as a rubric, what will I check? What will I check? What is the, yeah, what's the rule? Right, whether the AI used the chain rule or not. If I'm explicitly stating not to use the chain rule, and I set that as a rubric in my evaluation, stating do not use chain rule, or does the model use chain rule? And the evaluation comes out as yes, the model failed, right? It failed to follow my instructions. Similarly, if I said to the model, find me a flight from Delhi to Bombay, and don't give me flights from Air India, for example, right? Yet the model gives me flight options of Air India. How will I evaluate that? Simple rule, right? Do not give flight options from Air India. So just like this, we set tasks which are objectives for the model to complete. We build the environment in which the model executes that task. And then we set rules or rubrics that help us evaluate whether the model achieved that task with the right set of rules or not. And all of this goes back in as feedback to train the models again and again and again. And we do this hundreds and thousands of times until the models start beating the benchmarks that we set for it. And that is the whole concept of reinforcement learning. So, to do what we do, and at the scale that we do it, requires a lot of horsepower, right? We have some very strong partners, such as Amazon Web Services, to help us achieve these goals. We leverage the Bedrock platform offered by AWS, where we can find all these models and provides a high set of diversity for us to benchmark. Second is EKS, or Elastic Kubernetes, that allows us to spin up pods and run these environments thousands at a time. The AWS universe allows us to go and partner with other enterprises, which also require such fine-tuning services. And that allows us to hit a global reach. In the beginning, you saw a number, 50 billion tokens. We are not using these tokens. We are practically burning them. We're burning them to find the breaking point of AI today so that we can build the starting point for tomorrow. Thank you, everybody. That's my time. I'll leave the floor open to some questions. Yeah.
Any questions, please?
By when do you think we can bridge the gap to AGI?
Sorry, where are you? I can't.
By when can you think we can bridge the gap to AGI?
By when?
Yeah.
That's an interesting question. When we're able to solve for that graph, right? You saw the gap was extremely large. Now, fluid intelligence is something that is still in its research and experiment phase. And that's why creating these benchmarks is very important, right? So we can keep trying and testing and pushing the boundaries of AI and models today to understand where they are succeeding, but more so where exactly they are breaking, right? In my understanding, at least, there are a couple of domains in which models have become exceptionally good, right? One of them is software engineering. The other is English, well, languages in general, right? That a lot of data has been created and shipped there already. But there are also many areas in which models are not even coming close. And these are primarily the niche domains, right? Like the really edge of academia, right? Where engineering, for example, right? Electrical engineering, not even close, right? It's not able to build circuit diagrams and things like that. It's still struggling. It is able to, but at a very basic level, right? Designing a PCB, no way, right? Even playing computer games, like it's really struggling there, right? So I think AGI is something that is a bit of like a unicorn, right? Maybe it exists, maybe it doesn't. We don't know. But the whole idea is to keep pushing the frontier of models to understand how far we can actually reach.
Thanks. Thanks.
So on
So,
ba-
so my name is Spursh. Like the basic question I want to ask is like the way we know the way AI is developing, growing itself, whether it's RAG and LLMs or RAG pipelines, browsers where we use ChatGPT and new models are also upcoming. So even in the next 4 years, many things gonna change in the tech industry or many other AI. So like as a fresher, as a BTech first year student, we have many of as a theoretical learning we do in a BTech, right? But to be honest, we need in AI in this AI era we need a practical learning, a new learning in a basic need that we need to actually get a job in a AI corporate service. So like what will you suggest for like in a 4 year roadmap to like guide in a way that upcoming AIs like we can use and other stuff like
Yeah,
AI models?
absolutely. I think this is a very important question.
Yeah.
And I think this pertains to every person in this room, right? Um, Regardless of if you're trying to get a job or start your company or whatever it may be, right? So I think the first thing is that don't worry so much about RAG and graph RAGs and all these fancy concepts, right? I think the starting point, and I'll tell you why, right? Because these are evolving so fast that by the time you graduate, maybe you don't even have to learn how to build a RAG pipeline. Maybe you just prompt a model and it'll build it for you,
Yeah.
right?
Yeah.
So the idea here is not how many concepts you know, but how many concepts you've applied. Okay. So start with something very small, start with the basics, right? So agents is something that definitely is a starting point. And agents themselves can produce so much productivity, right? That RAG is just a byproduct or maybe a stepping stone to building agents today.
Yeah.
So, I mean, my question to you is actually, how many agents have you built till now?
Like to be honest, not at all. Like for now, I'm just exploring like in a way, but I can start and a basic structure from I can build something or start.
Absolutely.
Yeah.
So, all of these frontier labs like Anthropic, um, your Google DeepMind, right? Even OpenAI, all of them have exceptional learning material on their websites. In fact, they have launched learning and development programs and certifications for just people like all of us to learn how to use these models more efficiently. So anyone who's trying to learn AI, right, and trying to understand how to use it to maximize productivity, the first thing you should do is go on Anthropic's website and learn how to use Claude properly. Because I feel like everyone here uses Claude or Gemini or ChatGPT, but you really don't know how to harness the full potential of the model, till you actually understand the different frameworks, different projects to apply it on.
Yeah.
And from there, you sort of pick it up, and then RAG will become a part of the learning process, right? If
Yeah.
you try and start with RAG, it's like you're trying to start from the middle, right? Which is never a good place to start. So start with the very fundamentals, right? And the best place would be to learn from these websites and courses that they offer themselves.
Yeah. Thank you.
Yeah, welcome.
So, on behalf of everyone here, I want to extend a huge thank you to Mr. Suryansh Rana for that incredibly insightful and inspiring session.
Thank you.
Now, I would like to invite Ms. Simi Tiku, Director Placements and Industry Collaboration, School of Business, to kindly come forward and present a memento as a token of our gratitude and appreciation.